Hello from Wombourne in Staffordshire, and I'm up here today to attend part 2 of Simon Keeling's Weather School. Thank you for having me.
That's a pleasure, John.
We're halfway through the day, halfway through the course.
And you've survived so far.
and I'm learning some of the dark arts of weather forecasting.
Of which there are many.
Yeah. Today I thought we'd just do a quick update for you. We're going to make a proper video about Simon and his course and so on, but I thought it would be interesting to just say hello and say I'm up here. And today we've been talking about skew T diagrams, which are amazing and will revolutionise your planning for flights. If you come with us over here to the screen, Simon will show you a skew T diagram that he's been showing us on the screen, which looks like something out of a science class really, with these blue lines and these red lines. In basic terms, because our viewers haven't got the whole day to understand this as we have, what does this tell us?
Okay, so the skew T diagram, like you say, it looks like alphabeti spaghetti, doesn't it, at first, when you're looking at this. Basically, what it is, it's a chart of height versus temperature, okay? So on here, what we're looking at is temperature, which is the red line. We're looking at dew point, which is the blue line. And the basics of it are that where the atmosphere is more moist, the blue line will come close to the red line. That, for pilots, is cloud. So what the skew T's tell us is how much cloud there's going to be, what the base of the cloud is, what the top of the cloud is, and if the cloud is just a cumulus cloud or if it's in various different layers. These things are the Bible as far as weather forecasters are concerned.
Now, why this is important is because obviously you can look at your forecast and you can look at your TAFs, but it doesn't really give you all the information, especially if you want to fly an IMC. You need to know how thick and how far you're going to have to go through that cloud before you come out the top. And we can tell from this chart that the cloud is here, what did we say, about 3,000 feet?
About 3,000 feet today, yep.
3,000 feet here is where the cloud base is. It goes up another 1,500, 2,000 feet.
Yep.
So the tops are about 4,500, 5,000 feet. And we can tell from the distance that these two are apart that we're talking about 6 to 7 octaves.
Yeah, about 6, 7, 8. Yeah, so broken cloud. Yeah, absolutely. You've learned so much today. You must have such a good teacher.
Bring up another skew T.
Right, okay.
And I'll have a look at it.
Do you want another look? Right, okay.
So Simon's just going to bring up another skew T.
Let's have a look.
Let's see if I have learned anything today.
Okay. So shall we look at, do you want to look at 3 hours time?
Go on
so
then.
Shall we have a look?
Oh, no, a different day.
No, different day. Right, shall we do tomorrow?
Yeah.
Shall we do midday tomorrow?
Oh, wow, that's a bit different from the one.
This is for Birmingham again. So just down the road from where we are. Go on, John. It's all yours. I want to go flying tomorrow. You tell me about it.
So we can see that this line changes direction here.
Yep.
So that's our base.
Spot on.
That's our base.
Yep. Okay.
You'll have to tell me what 900 millibars
it's about
is.
900 millibars. So our surface pressure is a bit higher tomorrow. So just as an estimate, 3,500 feet.
Our tops are here.
Yep. Tops are there.
And that's going to be 1,500 feet above that.
Yep. So we're looking at tops with margins of error. You'd probably say about 5,000 feet.
And they're very close together.
Yep.
I won't do it properly, but I would imagine that we're looking at broken to overcast skies there.
Spot on. Yeah, absolutely. And what about above? What about here?
We've got dry air here.
Yeah.
So this is going to have clear skies above in this sector here.
Yep.
It becomes quite stable up here because we've got this grey line this side.
Absolutely.
Whereas it's unstable down here.
Okay.
But we might have some cloud forming up here. We've got another cloud layer just there.
That's good.
With tops about there.
And because it's 600 millibars, remember what we were saying earlier on, that you can actually make an estimate as to what the heights are, as to what the actual height of the cloud is. So 600 millibars is about 15,000 feet. So if you've got medium level cloud in at that height, that's likely to be either altocumulus or altostratus cloud. So if you were going to take off tomorrow, you're going to be taking off in what looks like pretty good conditions. You're going to be flying through perhaps stratocumulus, a little bit of cumulus cloud, but nothing that really is going to be too untoward. You're going to break through that at a top, like you said, of around about 4,500 to 5,000 feet. You'd be in lovely clear skies. But above you may just be sort of 4 or 5/8 of altocumulus or altostratus cloud. You can visualise immediately what it should be like when you're flying tomorrow.
So we have learnt some of the dark arts of weather forecasting, courtesy of Simon Keeling's Weather School. Thank you, Simon. As we say, there will be a proper big video on all of this about the course and what I've learnt from it. I'm also intending to go over some past flights where I've made some bad weather decisions, and Simon's going to tell me where I went wrong as well. So watch out on the channel, that'll be coming soon.
Come and have some cake now.
We need cake. We need cake. Let's go.
Let's go.